Hello and welcome to the session on test temperature sensor, pressure sensor, potentiometer, magnetic induction sensor, camshaft sensor, camshaft position sensor. By the end of this exercise, you will be able to identify the appropriate testing procedure for the temperature sensor, evaluate the pressure sensor readings, demonstrate the correct usage of testing equipments for the potentiometer. Tools and equipments required: trainee's toolkit, multimeter, vehicle, one tray and banyan cloth. Let's begin this session by testing the temperature sensor. The coolant temperature sensor measures how hot the engine coolant is. It sends this information to the car's brain, that is ECU, which then uses it to improve fuel and ignition timing. To test the coolant temperature sensor, follow a systematic process. Start by opening the bonnet to access the engine component. Locate the temperature sensor. Mostly it is situated in the thermostat valve area. Now turn on the multimeter. Select resistance mode and you are ready to measure resistance. Ground the multimeter's black terminal and connect the red terminal to the temperature sensor, measuring its resistance. Proceed by turning on the engine, allowing it to run for 2 to 3 minutes to reach operating temperature. Remeasure the resistance using the same procedure. A significant point of analysis lies in the difference in resistance between the initial and warm-up status. If the contrast is greater than 200 ohm, it indicates the temperature sensor is in good condition, effectively responding to temperature changes. The next task is to test the pressure sensor. A fuel pressure gauge provides visibility into the fuel delivery system's effectiveness, ensuring sufficient pressure for optimal engine performance. Inadequate pressure can lead to inefficient engine operation. Various sensors such as air intake pressure, atmospheric pressure, vapor pressure in the fuel tank and fuel injection pressure sensors play vital roles in a vehicle's performance. Despite the distinct role of sensors, their testing procedure remains consistent. To start the test, first identify the sensor's location within the vehicle. Once located, use a multimeter. Set to the DC millivolt range for precise measurements. Now start to run the engine. With the engine running, the procedure continues by grounding the black terminal of the multimeter and delicately touching the red terminal to the sensor. If the sensor is functioning correctly, you can observe a voltage reading within the range of 200 to 400 millivolt. In case where no voltage develops, it indicates a potential malfunctioning. In this case, it is better to replace the sensor. The next test is the throttle position sensor, that is the potentiometer test. Throttle position sensor, potentiometer test evaluates the sensor on the throttle body, measuring throttle valve movements and transmitting data to the engine control module. The faulty component is a spring-loaded mechanism serving as a throttle position sensor, TPS. In its resetting state, the TPS emits a low signal voltage of approximately half volt when the accelerator pedal is not pressed. The TPS relays pedal position to the engine computer, with higher voltage signaling and increased engine speed during pedal depression. A failing TPS may not trigger the dashboard check engine light, but a code scanner can unveil related trouble codes. Troubleshooting involves a digital meter set to DC voltage, jumper wire, and a needle or pin. The black meter probe connects to the battery negative or engine ground, while the red probe connects to the positive terminal. Inserting the needle into the TPS wiring allows voltage readings to identify the power supply wire, typically around 5 volts. This diagnostic procedure aids in detecting TPS issues, facilitating a comprehensive assessment of its proper functioning. The next sensor is the Crankshaft Position Sensor. The Crankshaft Position Sensor determines the crank's position and RPM. The engine control unit uses this data to regulate ignition and fuel injection timing, optimizing engine performance and efficiency. These sensors, known by various names like Hall effect sensor, CKP sensor, CMP sensor, pickup coil, magnetic pulse generator, and more. Let's see the simple procedure to test the crankshaft position sensor. Locate the sensor with yellow signal, black ground, and orange ignition wires. Check voltage with ignition on 12 volt on black wire to confirm battery connection. Use multimeter 20 volt setting, black lead on black wire. Expect 12.13 volt positive and 5 volt. Do not start the car. Turn on the ignition. For push start, position the timing gun until the lights come on. For manual, go to the second position. If the sensor is not installed, turn off the ignition after confirming voltage readings. Use a device or alligator clip for testing without opening wires. Connect black lead to engine ground. Expect around 5 volt. Attach metal to the sensor. Voltage should drop to 0. Repeat for consistency. A normal sensor switches between 5 volt, no metal, and 0 volt with metal. Irregularities indicates a faulty sensor. Let us understand the working of the camshaft position sensor. Identify the engine type, especially in newer engines with 2 camshaft position sensors, one for intake and one for exhaust, which may vary in engines with variable timing. Turn the ignition switch to the second position to illuminate the dash lights without starting the engine, preventing potential damage to the engine computer and fuses. The camshaft position sensor typically has 3 wires: ground, power, battery voltage, and signal around 4.8 to 5 volts from the engine computer. Use a cost-effective voltmeter to probe and identify the ground, power, and signal wires. This tool aids in precise determination of each wire's function. Connect the sensor wires consciously, considering the potential risk of engine damage as part of the diagnostics process. Highlight specific wire colors for easy identification. Example: green for ground, blue with orange for signal, and a voltage carrying power wire. Confirm proper sensor functioning by measuring a voltage of approximately 4.8 volt with the probes connected. Introduce a metal object such as a socket near the sensor. Observing the voltage drop to zero simulates the on-off behavior of the sensor, confirming its responsiveness to change in the camshaft's position. Let's get into topic of magnetic sensor. The ABS computer supplies a 12-volt reference voltage for the Hall effect wheel speed sensor. The sensor, featuring an internal transistor, responds to the reluctor or toothed wheel, generating voltage as metal teeth pass by. Hall effect sensor consistently produces a square wave signal, unlike magnetic sensors, maintaining a constant amplitude regardless of rotational speed. Manufacturers prefer Hall effect sensor due to their amplitude stability. To assess the sensor, measure reference voltage with a multimeter when the key is on and compare the sensor ground to battery voltage to ensure proper functioning. Use an oscilloscope to capture the square wave signal with its frequency indicating wheel speed. Test the sensor with the connector, both connected and disconnected. If connecting the sensor results in a reference voltage loss indicating a short circuit, replace it. Always use the APS computer as the reference voltage source. Let's recap this topic. In this topic, we have learned that the temperature sensor measuring engine coolant temperature adjusts fuel injection and ignition timing. The throttle position sensor, potentiometer, mounted on the throttle body, measures throttle valve movements. The crankshaft position sensor, CKP, determines crank position and speed, influencing ignition and injection timing. Magnetic induction sensor, composed of an electromagnetic coil, is tested by connecting a multimeter between the sensor and the engine control unit (ECU) to check for voltage signals during engine operation.